We're all searching for resilience, not only in the United States, but elsewhere in the world. People like yourselves are trying to come to an understanding of what it means to achieve resilience. And I wanted to start this talk off by pointing out that there are different domains. And some of us work in one of these domains perhaps more than others. But what we should be thinking about in regards to resilience is how we integrate across these. I think we've spent too long treating them as separable elements or units because there is a lot of interaction that we can take advantage of to realize better solutions. I mean, we have infrastructure that delivers service. We might think of a port that enables us to move material from one place to another. And we understand that that infrastructure is affected by events around it. For example, a flood, this image which you may recognize from Katrina in New Orleans as a levee is being overtopped. So the idea is to integrate across the domain. So my talk, I want to touch on each of these domains, and I think you'll see that reflected in the remarks that follow. We've built a lot of infrastructure in the United States. These are some statistics that reflect that energy over the 20th century. This is a lot of, I would say, concrete and rock and asphalt, right, when you look at these numbers. With some confidence, we can say that in the United States in the year 1900, we had exactly 119 dams in the U.S. So over a 100-year period, we built 90,000 structures called dams, which impound more than 600,000 miles of river containing 600 million acre-feet of water. Most of those dams have a flood risk management function. Okay? The question we might ask in looking at statistics like this is, what will the infrastructure we build and modify in the 21st century look like? Right? What are the opportunities to reconfigure that infrastructure, again, in the guise of this multiple domain of resilience? What does that look like? Are there Californians in the room? I can see some hands. It's hard with the lights. Anybody here from the San Joaquin Valley of California? Yell out if you are. We're here. It's good to be with you, sister. I grew up in a small town east of Fresno, California, nestled up against the foothills of the Sierras. This is a big valley, the Central Valley of California. It's about 50 miles wide and 450 miles long. And it's divided into two parts, the Sacramento Valley in the north and the San Joaquin Valley in the south. Has anyone read this book, The Garden of the Sun? It changed my thinking a lot when I read this history of the San Joaquin Valley. The first European to go into the San Joaquin Valley and to document what he saw was a man named Pedro Fages, a Spaniard, in 1772. And this is what he wrote. He saw a great plain, and in it some immense tule marshes with many large lakes and rivers. The San Joaquin, which discharges into the estuary that name is more than 120 leagues in length and places 15 to 20 in width. And in it winds through a plain which is a labyrinth of lagoons and tulares, these tule marshes. The plain is thickly peopled, having many large rancherias, and abounds in grain, deer, bear, geese, ducks, cranes, indeed every kind of animal, terrestrial and aerial. The Yokuts and the Miwok Native Americans actually built boats out of these tule rushes so that they could move across the streams and the rivers and the lakes of the San Joaquin Valley. They also fished on Tulare Lake. In the 19th century, Tulare Lake was the largest lake west of the Mississippi River, encompassing 600 square miles in the San Joaquin Valley. It doesn't exist today. Why? Because of the construction of the Terminus, the Success, and the Pine Flat dams, which impound the rivers, the Kings River, the Kaweah, and the Tulare, and the Tule River. That land is farmed today, that 600 square miles, where the lake once was. This is what the San Joaquin Valley looks like today. It's a patchwork. It's one of the most productive agricultural areas in the United States. The Central Valley overall in California is responsible for half of the fruit, vegetable, and nut production in the United States. But there are problems with resilience in California with respect to the management of water, both in terms of drought as well as flood. In fact, those dams that brought to an end the existence of the Tulare Lake were built because of floods in the 30s and the 50s of the lake itself. There is evidence that I think is clear, and it was already mentioned in the opening remarks this morning, that we need some innovation in our practice. In the upper left of this figure is the occurring event in the Midwest, something that we maybe almost can see ourselves becoming accustomed to, but we should not. Evidence perhaps that the infrastructure system is supercharged, right, and pressurized. Sandy and Katrina were mentioned this morning, two devastating events. Further evidence, I think, of the need for innovation and how we manage floods. Which brings me to this initiative we have within the Army Corps of Engineers, which we call Engineering with Nature. We began this initiative formally in 2010, so we're in our 9th year of this effort. And you can see the definition here, where we're seeking an alignment between what we achieve with infrastructure and engineering with natural systems, so that we can produce a better outcome and deliver a broader range of sustainable benefits through that interaction. And we're interacting with a number of organizations within government, outside of government, as we pursue this initiative. We're engaging across the Corps in our districts, implementing in the field projects that have these elements within them, seeking to use these ideas to find better solutions to infrastructure problems. The strategic plan for this initiative, there's several copies in the back of this room and also at the Corps of Engineers booth here today. Engineering with Nature has applications across our main business areas within the Corps of Engineers, including flood risk management, but also within navigation and water operations, and also within navigation within ecosystem restoration. One of the ideas or concepts within the context of flood risk management is what we call natural and nature-based features. And you see the definition here. We're talking about landscape features, right, that deliver flood risk management value, for example, in the form of flood storage, while also producing other kinds of benefits or functions, including environmental and social. And we've produced written material going back to 2013 on how natural and nature-based features can be incorporated into flood risk management practice. One example of this is a study that the Nature Conservancy and others conducted with support from the Lloyds Foundation, where they asked the question, what value did the existing inventory of wetlands provide during Hurricane Sandy? They applied insurance industry tools to answer that question, insurance industry models. The number they came up with was $625 million of avoided damages due to the presence of wetlands during Hurricane Sandy. I've translated this to a current team now, exploring opportunities in the Back Bay of New Jersey. If Todd could snap his fingers and all the wetlands in the Back Bay of New Jersey disappeared, would our flood risk management problem be more complicated? And the obvious answer to that is yes, it would. So the question is, how do we support and sustain or enhance those wetlands into the future to deliver more flood risk management value? Some other examples of this, levee setbacks and modifications that we're familiar with. The three pictures here show a progression in scale of application. The Puyallup River, it's about 100-acre flood plain restoration in that river. On the lower left at Alkborough in the UK on the Humber Estuary, it's 1,000 acres of flood storage, which has only been filled once during a tidal surge event in 2013, but the Environment Agency in the UK estimates that that one project reduced water levels by 10% at the levee at the city of Goole upstream. And then the Nordvard project, a similar project, a levee kind of realignment, a 10,000-acre polder, which is now open to the water and receives floodwaters, a combination of wildlife area and agriculture in harmony. Other examples of these kinds of practices would include what we're doing, the Corps in the Back Bay of New Jersey with our partners at the state and at the federal level and the private sector as well. Restoring islands, making plans to build new islands in the Back Bay to provide landscapes that contribute to resilience of the system. On the West Coast, we have these restoration projects at Hamilton, a Corps project, 500 acres of wetland restoration, and also at Sears Point, Sonoma Land Trust doing similar sorts of restoration, returning land which was once a part of the estuary but was diked off for low-yield agriculture, returning that back, if you will, to the aquatic system. Some of you may be familiar with Measure AA in the greater San Francisco area, right? Raising nearly, I think estimates are, $500 million over 20 years that's going to be devoted to restoration to be able to support resilience in these forms. One of the things I think our team needs, and our communities as well, is, well, what do these ideas look like of engineering with nature? So we undertook developing a book. It looks a lot like a coffee table book, and it was intentional to do so. It puts an emphasis on what these projects look like. There are copies of this book here with me now and also at the Corps booth that you could take a look at. But the electronic version of this is available to anyone free on our website in the form of a PDF. There are 53 projects in this book from around the world. 26 of these projects are existing Corps of Engineers projects, which have incorporated these principles into delivering infrastructure value. But this can help us stimulate ideas and other teams about what they can do and how they can do it differently. I'm pleased to say that planning for Volume 2 of this book is already underway, and this slide announces to you and invites you to submit project examples that you think reflect this practice that we can consider in assembling the next 60 projects that we can share with each other around the world on doing work in this way. Go to the website and you can download the form. It's a pretty easy process. And we need ideas. Many of you are aware of the fact that the Corps in the supplemental budget in 2018 received an additional $17 billion. $15 billion of that is going to active construction now. This is the distribution of those projects. The numbers in the circle represent the budget for those individual projects. This is a lot of work. And we are working with teams within the Corps of Engineers to infuse these ideas as those projects go through the various phases of design and implementation, including the biggest project on that list, Sabine to Galveston. Itself is almost a $4 billion construction project in which new levees that don't exist now are going to be built from the ground up. So how do we integrate natural systems into the functioning of that system to deliver more sustainably and reliably in the future? Some other examples of practice that we're doing is infusing landscape architecture into our business within the Corps. Of course, we have landscape architects, some of whom are here, Ellen. And there are great ways in which landscape architects and their capabilities can contribute to revealing ideas that maybe are a bit off the beaten track, right? Or not necessarily things that would come to the mind of the conventional engineer, if you will. So we're taking landscape architecture teams and from private practice and from universities into Corps of Engineer project teams so that they can think about ways in which they can incorporate environmental and social value into projects as they are modified and supported and enhanced. And this is just a listing of some of those, including that Sabine to Galveston project. In addition to ideas, that we want to be able to incorporate into teams and new projects. Teams need guidance, technical guidance. And so for the last almost 3 years, we've had an international team of more than 75 individuals who have been contributing across about a dozen countries, including 50 different organizations, the development of a technical guideline on the use of natural and nature-based features for fluvial river systems as well as coastal systems. So we envision this product will be released next year in 2020 as a 400-ish page technical guide on how to incorporate these kinds of strategies into our infrastructure projects. We just had our last working meeting in Edinburgh, Scotland last week. I returned late Saturday night and then regrouped Sunday and then got back on the plane Monday morning to come here, in which we saw some great examples in Scotland, in which they are incorporating river restoration to be able to relieve flooding problems in Scotland, in addition to other activities. Training is important as well. We've had a couple of training courses with the kind of the incipient guidelines that are coming forward. At the International Conference on Coastal Engineering, we had about 40 people spend a whole Sunday with us learning about these approaches. At Restore America's Estuaries annual conference in Long Beach this past December, we had 80 people spend a day learning about these techniques, and so our expectation is we'll have 160 after that, and 320, and on it goes. We're also working with academia, with 3 schools currently now, Texas A&M, University of Georgia, and the University of Oklahoma, who are interested in incorporating this type of engineering with nature, if you will, into their educational approach of engineers. So we're working with them to develop new curricula, new coursework. Both the Texas A&M and University of Georgia's courses in this topic area will be offered to engineering students so that the engineers of the future are more familiar with these kinds of solutions and how to build them. We also need to talk with a lot of people, including politicians and the staff of politicians, and with the Nature Conservancy and Caterpillar and AECOM. We joined them at an event on the House side in March, and then also on the Senate side in April. There was a lot of interest. We took them copies of the atlas. They could see what these projects look like and contemplate how investments in a future infrastructure bill could be enhanced through these kinds of approaches. Finally, one last slide for you. Mark Clark's a geographer, and he put together this image. If you could imagine a satellite flying in the air in the year 1851, and it looked down on California, what would it see? And you can see in the San Joaquin Valley, I mentioned to you earlier, Tulare Lake. Do you see it there? That's a much different image than what the San Joaquin Valley looks like today. I'm not using this image to suggest that we need to target going back to 1851. We know that's long in the past, and we will never be there again, right? But the question is, how can we use engineering with nature, right, to realize, to pull forward some of the functions and values and benefits that were associated with that landscape in 1851? Engineering has progressed tremendously in the last 150 plus years, and I know that it's within our capacity to do that. Thank you.